the instrument landing system, or ILS, is called a precision approach, since it provides both course and vertical guidance information. Because it's so accurate, you can usually descend to a lower minimum altitude than with other approach procedures. Lateral guidance is provided by the localizer, which radiates a navigational signal along the runway centerline. When the signal is projected in this manner, it is called a front course localizer. Just like a VOR, you should identify the localizer by listening to its Morse code identification, which consists of 3 letters preceded by an I. This is especially important when 2 or more localizers are operating in close proximity to each other. For example, the localizer for the ILS runway 27 left approach at Miami International can be identified by IMIA. While the identification of the localizer for the ILS runway 27 right approach is IVIN. Inside the cabin, course guidance is provided by the course deviation indicator on your VOR equipment. When you are flying inbound along the front course, the CDI tells you if you're drifting left or right of the runway centerline in much the same way as when flying along an airway. However, with an ILS, the instrument is much more sensitive. On a typical ILS, full-scale deflection occurs at 2.5 degrees rather than the normal 10 degrees with VOR. Theoretically, then, you should be able to track the localizer course 4 times more accurately than a VOR radio. With increased sensitivity, the CDI reacts more rapidly. Therefore, you will need to make smaller course corrections and make them more promptly. A unique characteristic of the localizer signal is that it provides only one magnetic course to the runway. This means that no matter where you set the OBS, the needle senses your position only in reference to the specific localizer course. In actual practice, it's a good idea to set the published ILS course on the azimuth ring as a reminder of the proper course and to help with heading corrections. The localizer also transmits a signal in the opposite direction, which is called the back course. Navigating on this segment requires special considerations. The only time you are authorized to navigate along a back course is when an approved instrument approach procedure exists and you have a clearance to fly the procedure. When you fly inbound on the back course, you experience reverse needle sensing on the indicator. This means you have to fly away from the needle to return to the localizer. Reverse sensing also occurs when you fly outbound on the front course. A simple rule to remember is that whenever you're flying on the same heading as the front course, normal sensing occurs. This means that when you are inbound on the front course or outbound on the back course, you correct toward the needle. When you fly a heading opposite to the front course, you must correct away from the needle. This occurs when you are inbound on the back course or outbound on the front course. Some localizer indicators are able to compensate and give you normal sensing during back course approaches. During an ILS approach, vertical guidance is provided by the glide slope. This signal allows you to navigate along a glide path to the runway. The glide slope transmitter and antenna are usually located to the side of the instrument runway centerline and 750 to 1,250 feet down the runway from the approach threshold. Normally, this signal is only directed to the front course, and since it is offset from the runway, it may not provide guidance all the way to touchdown. The transmitter operates on a UHF frequency, which is paired to the associated VHF frequency. When you select the localizer, you automatically select the associated glide slope. The center line of the glide slope is usually adjusted to an angle of 3 degrees above horizontal. However, this angle may vary slightly due to local conditions. False signals can also be generated at high angles. This usually isn't a problem if you intercept the glide slope at or near the altitude and position prescribed on the approach chart. On the ILS indicator, the glide slope is displayed by a horizontal needle. It operates similar to the CDI in that it shows your position with respect to the correct glide path. If the needle moves up, you are below the proper glide slope. If it moves down, you are above the glide slope. Fly toward the needle to return to the proper glide slope. The combination of the localizer and glide slope allows you to visualize your position along the final approach path. For example, this is the indication when you drift left and above course. To return to the proper approach path, you need to turn right and descend. An ILS also includes 2 or more marker beacons to provide you with range information along the final approach segment. The outer marker is placed between 4 and 7 nautical miles from the runway. Generally, the outer marker is placed at or near the point where you intercept the glide slope. The exact location is identified on the specific approach chart. A receiver in the airplane provides both an audible and visual cue when you pass over a beacon. The outer marker is identified by a flashing blue light and a continuous series of dashes. The middle marker is usually placed 3,500 feet from the landing threshold and intersects the glide slope at approximately 200 feet above the touchdown zone elevation. The middle marker is identified by a flashing amber light and alternating dots and dashes. Some approaches incorporate an inner marker that is identified by a white light and a series of dots. It allows certain qualified operators to fly an ILS approach to lower than normal minimums. Many ILS systems incorporate a compass locator that functions like an NDB to provide additional navigational information. Normally, it is co-located with the outer marker, although it might be placed at the middle marker as well. The compass locator may be used as a nav aid for the transition to the terminal environment or as an additional means of orientation during final approach. Some ILS approaches use DME to help you monitor your distance to the runway, as well as to provide a substitute for some of the ILS components. Where DME is required for the approach, it is indicated in the procedure name. The basic ILS is called Category 1. This type of approach is available for use by all current instrument-rated pilots. Normally, the minimum visibility is 1/2 statute mile or an RVR of 2,400 feet. When centerline lights and touchdown zone lights are provided, the minimum visibility can be reduced to 1,800 feet. The decision height is usually 200 feet above the touchdown zone elevation. A Category 2 or 3 ILS requires special certification of pilots, operators, aircraft, and air and ground equipment. Category 2 approaches normally provide for a descent down to 100 feet above the touchdown zone elevation and an RVR of 1,200 feet. Category 3 approaches allow descents down to the runway. They are further divided into RVR categories, with the lowest requiring no RVR minimums. Because of the complexity and high cost of Category 3 equipment, this type of approach is used mainly by air carriers and the military. Now let's use your understanding of the ILS components to fly an actual approach. We'll use the ILS Runway 4 approach at Amarillo, Texas. Assume you are on the feeder route from Cider intersection and have been cleared for the approach. The procedure will be shown as if it were in a non-radar environment. The feeder route requires you to track the 093-degree bearing to the Pandy LOM. Since you've been cleared for the approach, you may begin the descent to 5,300 feet. During this segment, you tune and identify the ILS approach facility, set the final approach course, and test the marker beacons in the airplane. As you near Pandy, you have a number of ways to identify the LOM. For instance, the localizer needle begins to center, and the ADF bearing indicator starts to move away from the nose. As you pass over the station, the marker beacon light flashes, and you hear the identifier. Instead of intercepting the localizer inbound, you must turn right, track outbound on a course of 217 degrees, and fly the procedure turn. Since you must remain within 10 nautical miles of Pandy, you should begin the procedure turn as soon as practical. A 2-minute outbound leg is usually sufficient to establish the course before you start the turn. The minimum altitude for this segment is 5,300 feet MSL.
Amarillo approach, Warrior 312 is Pandy outbound.
Roger 312. Report Pandy inbound to the tower on 118.3.
Warrior 312, report Pandy inbound on 118.3.
As you fly outbound, remember that you'll have reverse sensing on the CDI. If you drift from course, you'll have to fly away from the needle to return to the localizer. The approach chart shows the side of the localizer and the recommended headings to fly during the procedure turn. You can make the course reversal by flying to 172, then 352 degrees. As you complete the turn to a heading of 172 degrees, you should note the time, since the recommended length for this leg is 1 minute. When you have completed the initial part of the procedure turn, make a 180-degree right turn to 352 degrees. You can verify that you are approaching the inbound course when the CDI begins to center, and the ADF nears a relative bearing of 45 degrees to the Pandy LOM. Your minimum altitude from the procedure turn inbound is still 5,300 feet until you intercept the glide slope just before you reach Pandy. Your primary concern at this time is to stabilize your airspeed and altitude, and find the heading that maintains the localizer centerline. Intercepting the glide slope at the proper speed makes the descent more stable. This is also a good time to verify the decision altitude and height for the approach and the missed approach procedure. As you near the glide slope intercept point, the horizontal needle begins to move down toward center. As the needle centers, you must make a small pitch, power, and trim adjustment to establish the proper descent rate and maintain the airspeed. It's a good practice to note the time as you pass the outer marker. If the glide slope stops working, you can still continue with a non-precision localizer approach, since you'll have the timing needed to identify the missed approach point. This table provides timing information to the missed approach point, as well as the rate of descent for the approach. If you are stabilized on the glide slope, you can verify your ground speed by comparing your actual rate of descent with the table. For example, when established on the glide slope, you note that your VSI is indicating a 510 foot per minute descent rate. Since this indication is about halfway between the corresponding rates for 90 and 100 knots, you can estimate that your ground speed is approximately 95 knots.
Amarillo Tower, Warrior 81312 is Pandy inbound.
Warrior 312, cleared to land, runway 4.
As you continue down the glide slope, you should monitor your progress toward the decision altitude and height. As you approach the decision altitude, begin to look for the approach lights and other indications of the runway environment. The missed approach point on this ILS is located where the glide slope intersects the decision altitude of 3,805 feet. If you have the required visual references clearly in sight and can make a normal landing at this point, you can continue the approach. If not, you must immediately execute a missed approach. Even with the runway in view, don't completely disregard your instrument scan as you descend to land, since it's possible to enter low-level clouds or fog. When compared to other types of instrument approaches, the ILS offers a better opportunity to complete your approach and landing in poor weather conditions. When you combine the precision provided by the ILS with careful pre-flight and in-flight planning, you will find that flying the approach is both simple and easy.